In this section of the course, we'll take a quick tour of the CodeLight IDE interface. It's important to feel comfortable with the environment that we're using to create our C++ programs, so I'll walk you through the major functionality of the CodeLight IDE so you can get up and running quickly. Then we'll write our first C++ program. It'll be a pretty simple program that simply asks the user for their favorite number and then displays it on the console. We'll use this program to look at the build options provided by CodeLight, and I'll show you how they work and what they do. Finally, we'll introduce some problems into our program so that you can see some of the typical errors and warnings that you'll probably encounter as you write C++ programs and understand them and know how to fix them. That's it. This section's short and simple, but very, very important since it lays the foundation for writing, building, and running C++ programs in the CodeLight IDE. Let's get started. In this video, we'll take a look at the main elements of the CodeLight IDE, or Integrated Development Environment. Now, integrated development environments are really nice because they allow you to build and compile and edit and debug and do everything from a common interface, but they can be pretty complicated as well. Now, the CodeLight IDE is a fairly simple IDE as far as IDEs go. If you use Microsoft Visual Studio or if you use Xcode and Eclipse and others, they're much more complicated and they've got a lot more bells and whistles. But CodeLight's a great IDE for C++, especially when we're learning. So let me go over some of the main elements here. When you first start CodeLight, you have an interface that looks like this. This is the main default interface, or perspective as it's called in CodeLight. Over here on the left, you have the workspace pane, which is this little rectangular area right here. Here, in this large area, we've got our editing pane. This is where we're going to be editing and typing our source code. And then we've got an output pane down at the bottom, and you can see that each one of these has a lot of little tabs in there, and I'll break that up so you can see it a little better. So here we've got a workspace tab, an explorer tab, and so forth. And I'll go over what those do in just a moment. Now, at the moment, there is no workspace at all. So we need to create a workspace, and then we need to add projects to that workspace. So let's do that. Let's create a new workspace, and we can do it right here. We can select new workspace right on the main menu here, or we could go up to a workspace, new workspace, or we could go to file, new workspace. You can choose whichever one you like. I'll choose this one right here, and I'll give the workspace a name. In this case, I'm going to call it Section 4 because this is a video in Section 4, and that way we can create all our Section 4 projects right within this workspace. The path for the workspace you need to provide, I'm going to select my CPP examples folder, which is on my desktop. I'll select that, and this will create that workspace within that folder, and I'll select OK. Now you can see that we've got a workspace here called Section 4, and a couple of other things have popped up here. You can see there's a debug drop down, and we'll get to all that in just a bit. So at this point, we need to create some projects. Notice that there is nothing to edit here in this window. It's empty because there are no C++ files ready for editing yet. So let's create a project. This is going to be very similar to the way we created the projects in the installation videos in the previous sections. So I'm going to right click on Section 4 workspace, and I'm going to say new project. At this point, I'm going to select that default project template that we created. In this case, I called it Frank Default G++ Project. So I'm going to select that, press next, and I'm going to give this project a name. I'm just simply going to call it Project 1. I'll select next. I'll accept these defaults, which is my compiler and debugger, and I'll select finish. So now you can see I've got a project named Project 1 under my Section 4 workspace, and you can see there's the main CPP file. If I double click that, it will open up in the editor, and it's just going to say hello world. We'll get to building and running this in the next video. But for now, let's create another project, because remember, we can have multiple projects in our workspace. So I'm going to go back up to my workspace, right click, do again, new project. I'll use the same template, and I'll just call this project 2. And press next and finish. Okay. So now you can see that we've got 2 projects within the workspace. Also notice that project 1 is italicized and it's bold. This tells you that this is the current project or the active project. Now, I can select the main CPP in project 2, and you can see here we've got 2 C++ files, one for each project. Now, you'll notice that when I select these tabs, you'll notice I select this tab and this highlights right here. So this tells you that this is the main CPP for project 1. when I select this tab here on the right, this main CPP lights up for project 2. If you're not getting that behavior, then this little link right here is probably not selected. If that's unselected, then you'll click on these and this won't change at all on the left side here in the workspace view. So you want to make sure that that's selected. That way it links the editor to the workspace files. So there we go. We can switch between them very easily. So let's change this source code. I'm going to select this file right here, and I'm just going to say hello project 1. And I'm going to save it with Control S or Command S. And I'm going to select this guy right here, and I'm going to say hello project 2. That way we'll be able to see the difference when we run them. And again, I'm saving it. We could also do File, Save. That's it. Now, suppose I want to change between projects. So here, notice that project 1 is the active project. You can select the active project just by choosing it here from the download list. You can see when I hover over it, it says select the active project. So that's as simple as that. You can also double click on the project name. So if I double click on project 2 is now the active project. Project 1 is now the active project. Now, what does active project mean? Well, when I build a project, let's say I come up to my build and I say build something, run something, clean something, and I'll get to all this in the next video, it's going to apply it to the currently active project. It's real important because suppose that now you're here and you're modifying this source code here, and then you build and you see nothing's changed. Well, that's because this project 2 is not active. Project 1 is the active project. So when you build and run, it's going to run project 1. It may seem like this is pretty hard to keep track of, but it's really not. It's really easy to keep track of what project is active. And using this little link editor, you can obviously see which file you're working on. So it's pretty easy to do. There's a couple of other things that I wanted to talk about here. In the editor window here, you can see that we've got line numbers selected. Okay, so that the IDE is displaying line numbers for us. This is handy because the compiler errors will give you line numbers, and it'll also throw you a little error right here. It'll show you a little mark that says, hey, the error's here, which is kind of nice. I'm going to keep the line numbers on for me. You can choose to not use them if it distracts you. But in the course, I'll refer to line number 7, line number 5. That way it's much easier for you to follow along. If you want to get rid of those line numbers, you could just go up to Settings, Preferences, and right under Editor, you could say Show Line Numbers in the margin, and you could just uncheck that. There's a whole bunch of other options. The other thing you might notice is, you'll notice right here to the left of the int, there's a little triangle. That's called a code folding triangle. So if I select that, you can see what happens is, notice I've got active right now, lines 3, 4, well, I've got all my lines, right, from 1 to 8. But when I select that, it hides lines 4, 5, and 6. And you get this horizontal line showing you that, yeah, there is stuff in here. I'm just hiding it right now. This is called code folding. It basically just hides that code. This is real handy when you've got hundreds and hundreds of lines of code in your file and you're scrolling through trying to find things. It's really, really nice to be able to just fold some stuff up. In other words, I'm working on this function right now. I don't need to see all the other ones. I just fold them out of the way. We'll get to use these features later on as our programs get bigger. But if you find yourself in the position where you've clicked on that by accident, and you see this line and you're thinking, oh my goodness, where did my source code go? Don't worry, the source code is still there. Again, if you see that horizontal line, just click on that little triangle and it will show it for you. Also notice that the editor uses color coding to display certain things. So for example, you can see that int and return are a purple color. And you can also see that hello project 2 here is in this dark blue color. We've also got things in dark green, light green, and so forth. Also notice that the integer 0 is red. So there's rules that the IDE is using behind the scenes to make it easier for you to figure out what's going on. So one of the rules that is, it's saying, hey, you know what? If you're seeing a reserved word or one of the keywords in C++, make them purple. You can tweak all of this by going to Settings, Colors and Fonts, select C++ here on the left, and you can customize the font that you want to use for your keywords and so forth. I recommend you just leave this alone unless you have a real problem with some of the colors that are there. Okay, so that makes it really easy to figure out what's going on. So for example, let's say I forgot this quote right here. You can see that that entire thing is now a dark blue. That tells you something's not right. So we can always use that coloring to help us out. It's the IDE trying to make life easier for you. The output pane down at the bottom This is where our compiler messages will be displayed when we build code. It'll tell us what we're building, the status of the build, and so forth. It'll also be handy for doing global search and replaces, both at the workspace level and at the project level. I mean, sometimes you want to change a name from hello to hello there, and it's really easy to do a global search and replace. There's a bunch of other tabs here. These tabs, we're not going to use most of them. I'm basically just going to leave them alone. But if they bother you, you want to get rid of them, you can click on these three horizontal dots right here, these three vertical dots rather right here, and you can select to hide certain things. So let's say we don't want to see the Build Queue tab. Just select Build Queue and it hides it. You can always bring it back if you like. Like I said, I'm just going to leave them alone. But if your screen real estate is small or your monitor is small and you're having trouble, fitting all of this stuff in, this is a real easy way to do it. The ones we're going to use the most are build and output, and obviously search and replace can come in very handy. Okay, now in the workspace view, we've also got some tabs. Now here, I'm going to spread this so you can see it a little bit. The only ones we're really going to use here are Workspace, Explorer, and Tabs. These last three, Tab Groups, CMake Help, and WX Crafter, we're not really going to use them. So what we can do is we can hide those. So again, I'll select the three dots, and I'll hide WX Crafter, I'll hide CMake, and I'll hide Tab Groups. That's it. That makes it a little less cluttered, and it's kind of nice to see it all there. This little drop-down arrow here, if I'm in Tabs and I select Download, I can go to Workspace. If you only have 3 tabs, it's not really a big deal, but if you've got a lot of tabs, then it's real nice to be able to do that, especially when they're hidden and you can't see them in a situation like this. So the last thing I want to do is I want to show you that you can actually move these panes around. Now this is the default perspective that you get out of the can. Some people don't like the workspace view on the left. They prefer it on the right. So you could just grab the workspace view tab right here and just move it over, drag it to the right, and you'll see it light up. You can see here, if I wanted to put it down here, it lights up. The area that it's going to be in lights up. Again, at the top, you can choose to put it wherever you like. Let's say you like it over here on the right. And some people like this workflow a little better. So now you've got your workspace here on the right and your editor on the left. You can do the same thing with this output view. I mean, suppose I want to put my output view right under my workspace view. I could do that. Now I've got a really large editing area. It's totally up to you, the perspective that you use. This is a real personal decision. I've worked on teams where everybody on the teams of hundreds, everybody's got their own way of doing things, so everybody tweaks the environment their way. The nice thing about this is that if you download some project and it's got this perspective saved, you can always come up to perspective and click on default layout, and that'll bring it right back to the default. So I can just select that, and here I am back to scratch, just like it came out of the can. If you prefer your layout to be a specific way, let's say I like it like this, and I want to move this over just a little bit here, and this guy's up here like that. Again, however you want to do it, you can come up to perspective and then save current layout as. So let's just say I want to call this Frank.layout. And I can save it. So I can switch between the default layout, and if I want to go back to my own layout, I can go back to Frank layout. Really, really easy to do. There's 2 layouts that come already pre-configured. One is the default layout, which is the one I've shown you before, and the other one is the debug layout. This is the layout that's used when you're doing debugging. So if I select debug layout, you can see that I've got an output view pane on the left and a debugger pane on the right. And CodeLight will switch to this automatically when you go into debug mode. Again, if you have a better way of doing it that works for you, you can tweak this and save that perspective. So I'll switch back to the default perspective. And we can also use the view options to hide or view different panes. So for example, if I don't want to see the output pane or the workspace pane, I can certainly hide them and view them. I can also do that here by closing up with that little X right there to close up the workspace view. I can also make the workspace view really large by clicking this icon right here. So you've got all these options, and I encourage you to play around with the environment and set it up to a place where you feel comfortable working. Recall we talked about this in one of the installation videos, that we can show a toolbar so we can build and run and save and have all kinds of options by just clicking on these toolbar icons. I'm not going to use that since it really clutters things up for me, and I want to be able to explain exactly what I'm doing. So for example, that icon right there says Run Active Project. That one says Start or Continue Debugger. So they can be confusing at first. I'm not going to use those. I'm simply going to come up here and tell you exactly what I'm doing. So I'm going to close the toolbar down, but again, feel free to use it. And that wraps up this quick tour of the CodeLight IDE. We are certainly going to use more features as the course progresses. In the next video, we'll create our first C++ program that goes a little bit beyond the Hello World program. And we'll use that program to understand how the build process works within the CodeLight IDE. In this video, we'll write our very first program. So what we want to do is we want to create a project. So again, I'm in the Section 4 workspace, and I'm going to right-click on there and say New Project. I'm going to select my default template again, and I'm just going to call this First Program. And I'll select Next and Finish. Now notice that Project 1 is the active project, so I want to be sure that First Program is the active project. So I can just double-click on it, and I can open up that C++ file. That's it. So this is the source code for the first program. Now what I want to do is I want to erase this, and I want you to really just type it in. That way you get used to typing these things in at the beginning, and that's probably the best way to do it, is just to follow along. So let me tell you what this program is about. This program is going to ask the user to enter their favorite number, a number between 1 and 100. And then it's going to display, wow, that's amazing, that's my favorite number too. That's it. Okay, so let's start. First thing we need to do is we need to do #include of IOStream. Now, as I type, I'm going to press IO. Then when I press S, you can see that the code completion is helping me out. It's trying to figure out what I want, and it's giving me its guess as to what I want. And I want IOStream, so I'm just going to select it and close it. There is no semicolon here on this statement. These pound directives, and we'll talk more about what these preprocessor directives are in Section 5, but they don't take semicolons at the end. So I'm going to press Enter. And now we want to create our main function. Remember, the main function is the main entry point. This is the place where execution begins. So we're going to say int main left paren right paren. And then we're going to put a left curly, and the IDE will terminate that left curly with the right curly. We'll talk more about style as we go, but some programmers like to line up their braces like this. Others like to line them up like that. Right now it doesn't matter. Let's just line them up like this. All right, so what do we need to do? We need to prompt the user to enter their favorite number. So how do I do that? I do that with a cout statement. So I'm going to say std, 2 colons, then cout, and we'll do the insertion operator, which inserts something into that stream. Remember, cout is typically tied to your console, your terminal, so the user can type things in. And we're going to display enter your favorite number between, let's say, 1 and 100. And I'll just put a colon there. Now you'll notice that you've got a quote mark and then a terminating quote mark. This is called a string. This is called the string literal. This will be displayed exactly as is. Now, this is a statement, so all statements end in a semicolon. Remember, main returns an integer, and that integer is 0 if everything is good. So I'm going to return 0. Right? So if I run this program now, it's all it's going to say is enter your favorite number between 1 and 100. That's it. It's not going to grab the number from anywhere. It's not going to display anything else. We need to somehow read what the user types in on the keyboard. So just like cout writes to the console, cin reads from the console. So what we're going to do here is we're going to say std cin, and now we're going to use the extraction operator because we want to extract information, and it's the same as the insertion operator except going the other way. But now what we're saying is we want to grab whatever the user types in and we want to store it somewhere. Where do we store that? Well, this is where variables come in, and we'll do a lot of talking about variables in Section 6 I'll talk about how do you declare them, how you initialize them, the rules for naming them, and so forth. But declaring variables is very straightforward. So let's do that here. What we do is we tell the compiler, remember the compiler is really dumb. It's not guessing. It does exactly what we tell it to do. So what I'm going to do is I'm going to tell it that I want a variable name, and that name is called favorite number. That's where I want you to store what the user typed in. And you also have to tell it what kind of data that is. Is it a string? Is it some big, huge structure? No, in this case, it's just a whole number, an integer. So we're going to say int space favorite underscore number semicolon. That's it. That's a variable declaration. You've just told the compiler that this variable name right here, favorite number, is an integer. Now I can read information into that. So I can say std 2 colons, and again, the std will explain later on, it's a namespace, but we definitely need it here. std cin into favorite number. Now again, I'm going to type fav, and the code completion will try to figure out what I want. So it's going to use favorite number. I can just press enter. Semicolon on the end. So notice what we've done so far. We've included IOStream. Why did we include IOStream? Because we need the input-output libraries. We can't do I/O without it. So we're including it. Now the compiler understands about input and output. It understands cout and cin. They are defined in here. Great. So I'm outputting, enter your favorite number between 1 and 100. Now the user is going to type something at the keyboard, and whatever they type, we're going to store it into favorite number, this guy right there. All right, now we just need to say cout, and I can say something like amazing. That's my favorite number too. Here we can do an end line, so we flush the buffers and print out to the next line. That's it. So let's go through this again one more time. We've got a main function. This is the entry point. This is where execution begins. All C++ programs must have a main function. All C++ programs must only have exactly one main function. So when the program begins to execute, this is where it starts. Here I've defined a variable called favorite number, and it's an integer. It can only hold whole numbers. I'm outputting to the console, enter your favorite number between 1 and 100. The user is now going to input something into the console, a number, and I'm going to read it and store it into that location, into that variable, into that box. Then I'm going to say cout, amazing, that's my favorite number too. And I'm just going to print end line at the end. That'll flush out the buffers and move the cursor over to the next line. Finally, I return 0. Everything's good. Now, next thing to do is to build this program. The program's not going to run by itself. We need to compile it, we need to link it, and then we need to execute it. That whole process of compiling and linking is called building. Now, you'll notice that when you right-click on that source file right here, main CPP, you see it says compile. Now, if I press that, it's going to compile our program, and you can see here, 0 errors, 0 warnings. We'll talk about what happens if you get errors and warnings a little bit later. Also notice that we're using the C++ 14 standard, which is what we want to use. That's what we did when we set up that default template, if you recall. What we need to do next is to build the project by compiling and linking. That's going to create the exe file on Windows or the executable files on Linux and Mac. And we'll do that in the next video. In this video, we'll take our first program, which we've compiled to show that it's got no errors, and we'll build it. Now, if you recall, building means compiling, linking together with extra libraries and external files if we need to, and creating an executable file. That's what building is all about. There are several steps involved with building. The first one, obviously, is compiling. If we can't get a clean compile, then there's no way we're going to build the system. So we want to be able to compile and then link to create the exe file. Finally, we can run our executable. So in this case, you'll notice here's the source code. And there's a lot of space in here. Normally we don't have all this space in here. I just put it in because it makes it a little bit easier for you to read when you're first learning. So let's just keep it like that. This program is exactly the same as it was before. We're asking the user to enter their favorite number between 1 and 100. We're getting that number and storing it in a variable called favorite number. And then we're just saying amazing, that's my favorite number too. So it's really, really simple program. And we've already compiled it. There's a couple of ways to compile. One is you can come to the source file itself, right click, compile, or you can come up to build, compile current file. And that's only taking care of the compilation. There's also a lot of things you could do at the project level right here. So if I select the project and right click, you can see that it says build, rebuild, clean, stop build, and so forth. Let's talk about clean first. Now, think about this. When I compile a C++ program, I'm converting the CPP source code, this source code you see here, to an object format, right? A machine language or a binary format. That's going to create a .o file or a .obj file, as we mentioned in previous lectures. That's the purpose of compiling. Now, as your programs are compiled, they will have many of these .object files. The clean process removes all those object files and puts your project in a clean state. In other words, source code only, no object files. Now, why is this important? It's important because when you compile your programs and build your programs, sometimes you want to do a clean build. What that means is I want to start from a position where nothing has been built. I just want to clean everything out. Now, when we're working with a single CPP file like here, it's pretty much a moot point because it's just one file. But typically, C++ programs are very large, and you've got a lot of C++ files. Each one of them is being compiled to an object format. And when you say, hey, compiler, build for me, the compiler's only going to build exactly what it needs to build. So if it realizes that this source code already has an object file associated with it, and the source code hasn't changed, then why bother building it again, right? So it's not going to build it. And it does that to be efficient, which makes a lot of sense. But occasionally you want to do a clean that removes all of that stuff. It removes the exe that was created. And then you want to build again. So now we're going to get a clean build. Again, this is really not an issue here when we've got one CPP file. But if you've got thousands and thousands and thousands of files, there can be a significant difference in the amount of time that it takes to do that build. Okay, so in this case, I can come over here to the project. I could right click and I can say clean. And you'll see here the clean is complete. All it did was remove any object files and the exe files. Then I can say build. Now, when I say build, by saying build project here, pressing F7, or on Mac, whatever the command option is, or I can right click on the project and say build. Now what's going to happen here is it's going to go through your project looking at all the C++ files and only build what it needs to build. Okay, now in this case it's going to build everything because it's just the one file and I haven't built it yet, but it's going to not build what it doesn't need to build, and that's important to understand. Rebuild is the combination of a clean and a build. Okay, so when you say, hey, rebuild the project, it's going to do a clean, it's going to clean everything out, and then it's going to build it again. For the beginning of this course, all of these are going to be just fine. You can use rebuilds because it's going to be pretty quick. Finally, once we get a build, we can run the project. The way we do that is we come up, again, remember we've got the active project here. I can come up to build and run. Now, if I do that now, we have an option. We can simply execute the exe file if there is one there. Or we can choose to build and execute. I would generally tell you to select build and execute and probably remember my answer. Don't ask me again. It would be a pretty good idea because most of the time our files are going to be fairly small and a build is not going to take any time at all. So we can build and execute. Okay. So that's how you run. Let's say I want to do that now. I'm going to say build and execute. And there's my program. It says enter your favorite number between 1 and 100. Let's say I type in 24. Press enter. It says amazing. That's my favorite number too. Now, this time elapsed is how long the program took to run. This is being displayed in the latest version of CodeLight. Prior to this last version, you didn't see that, and I think it's Windows only it's being displayed. I didn't see that display on a Mac. When you run the exe file that's created from the command line, you don't see that. That's just mostly for FYI, so that you can tell as a developer, if there's something wrong and how quick your program's running. Press any key to continue. I'm done. Okay. Now, one of the things that I want to show you, notice this workspace view, which is where I'm at right now. And again, I've got 3 projects here. Each one has a main. Where's the exe files? Where are the object files? Where's all that stuff? They should be there, right? Absolutely, they should be there, and they are there. The IDEs generally hide that information from you because you don't need to know about it, really. I mean, do you care that there's an object file or an exe file? Really, what you care about is these error messages and so forth. But we have this Explorer tab, and that'll let you see all that. I want to show you what that looks like. You can click on the Explorer tab, and then you can drag any folder from your operating system, from your file system onto here. So I can just right-click, open folder, and I'm going to select from my desktop CPP examples, that section 4 folder. That's where my workspace is, and I'll select it. Okay. So you can see now if I expand this, you could see a bunch more stuff now. I've got a .CodeLight folder that has things that are related to my favorites and compilation and refactoring and so forth. I've also got my 3 projects, first program, project 1, project 2. I've got a make file, I've got my workspace file, but let's look at first program for a second. Now you can see a little extra stuff going on, right? Before all we saw was main CPP, now we see all this other stuff. These are the files and the configuration files that CodeLight is using behind the scenes. The IDE workspace here abstracts that out, since you don't really need to know all that information to build your system. It's building it for you. But if you really want to see them, you can, or you can just look right in your file system. Okay. Now, if I look in my first program debug folder, you'll see that there's my exe, firstprogram.exe. You can see it right here. And there you can see my .object files and .d files and all kinds of stuff that's going on. Okay. Now you'll see first program debug. Now what I'm going to do now is I'm going to clean first program, and all of this stuff should be removed. Okay. So again, I'm going to go to Build, Clean Project. Now, if I refresh this view by right-clicking up here, refresh, and go back to first program, you can see it's all gone. The entire debug folder is gone, the object files are gone, the exe files are gone, everything's gone. So now when I rebuild, all that will be created again. And now you'll notice that debug folder, right? Well, if I come back to my workspace, there's my first program. Notice that we've got build configurations here, and there's a couple. You've got debug and release. You can choose either one. We're going to use debug throughout the entire course because that's what we're doing. We're basically developing right here. Release is when you want to release the file to productions for your users to use. So in this case, debug creates that debug folder that you saw a little bit ago. If we do this in release mode, we'll get a release folder as well. So we'll have 2 EXEs. Now the difference is the debug configuration creates object files that has debugging information in them. It's got all those variable names and stuff. So later on when we debug our program, we can have all that information available to us, and it makes us very, very productive, and it really helps us debug and test our code. The release configuration removes all of that stuff, and it does more optimizations, and it just makes your exe leaner and meaner so that you don't need all that debugging information at runtime. Okay, so like I said, we're going to use debug. You can certainly use this if you like. If you do use this because you're curious or you want to see what's going on, don't modify anything from in here. I mean, as a matter of fact, if I try to open up this make file, you'll see it says auto-generated by CodeLight. Don't change it. Or even if you do change it, we're going to blow it away anyway. Okay, so you really don't need any of that. This is where we're going to be working in the workspace mode, but I just wanted to show you how that clean really, really works. Okay, so again, let's recap here. I can select first program, right-click, clean. That'll remove all my object files in the exe file. I can rebuild, in which case it will clean and build, or I can simply build, and that will only build what needs to be built. Okay, hopefully that makes sense. It's a little difference between them, but you should understand it's not that big a difference. Now, finally, we want to run. We come here to run. So let's do this one more time. I'll build and execute. Enter your favorite number. My favorite number is 100 this time. Amazing, that's my favorite number too. That's exactly what our program is supposed to do. Now you'll notice a couple of things here. One is, we're really not using favorite number, are we? I mean, the user's typing it in, but we're not really saying, wow, that's a great number, 13 that you entered, or 100 that you entered. And you'll do that in the challenge exercise in this section. But right now, we're grabbing it, we're storing it into that variable, but we're not really using it afterward. And like I said, in the challenge video, you will use it. So that's it. That's pretty much the build process, the compile process, the run process. It's fairly straightforward. If you've got the toolbar, you can click on buttons to do this. But in this course, I'll come up here and do these things, or I'll just right click here and do what I need to do here as well. That's it. Remember, you can also come up to the workspace and right click on the workspace, and you can build the entire workspace or clean the entire workspace. And that'll create exe files for all the projects all in one shot. Okay, that's it for that. Now in the next video, what we'll do is we'll talk about compiler errors and compiler warnings, and we'll mess around with this program a little bit. And I'll show you some of the common errors and some of the common warnings that you could get, as well as why they happen. Now, throughout the course, we're obviously going to see a lot of compiler errors. I make it a point that when I teach, I'm just coding along with you. So I hope I make some mistakes so that you can see some of the common compiler errors. I'm not trying to make them intentionally, but sometimes, you know, you forget a semicolon, or you forget to do this, or this is the wrong type. So that's important that you see these types of errors happening and you can know how to fix them. All right, so I'll see you in the next video. In this video, we'll talk about compiler errors and why they can happen. Programming languages have very specific rules about how to write code so that the compiler can translate that code to machine code. These rules involve both structure and meaning. For example, C++ says that all variable declarations must end with a semicolon. If we don't add the semicolon at the end, or we put it in the middle instead, then we have a syntax error. The compiler is complaining that the structure is not correct. In the first example, we didn't terminate the string error with a trailing quote character. In the second example, we left out the semicolon at the end of the return 0 statement. Both of these are syntax errors. There's something wrong with the structure of the code. Now, these syntax errors are pretty easy to fix, and the compiler errors usually give us pretty good information about what's going on. Semantic errors are a little different. In this case, the syntax or structure is correct, but the meaning of the code doesn't make sense to the compiler. Suppose we want to add two variables, a and b. If the variables are both integers, then this makes perfect sense. But what happens if one of the variables is a person and the other variable is an integer? Does it make sense to add a person and an integer? Probably not. In this case, the compiler generates an error. When we think of compiler errors, we really think about both of these classes of errors. Remember, compilers are very, very picky. Why? Because their job is to translate your code that you wrote into machine code that functions as you said. If the compiler has any problem understanding the meaning of your code, then it won't guess. It will generate an error. Let's head over to CodeLight and see some of these errors. So now I'm in CodeLight, and I created a project called Compiler Errors. And I created it right from our template, so it's just a simple Hello World program. It's just printing out Hello World. Now what we want to do is we want to introduce some compiler errors into this program so you can see what they're like. Now let's do some syntax errors. Simple stuff like, okay, we forgot this quote right here. And I can save and compile, and you'll see that I'll get an error that says missing terminating character, and if you click on here, it takes you here. Okay. Now, in this case, we've got another error that says expected primary expression before return. This happens sometimes. The compiler gets confused. It sees that first error, and then it's trying to figure out what's going on, and it goes to the next line, and it says, I don't know where I'm at, and it creates an error. Many times when you fix that first error, many of the subsequent errors go away. So let's put that quote back in. We'll save, and let's recompile. Now we've got a clean compile. So that would be my, my advice when you're first learning. Start out at the beginning, get that first syntax error fixed, recompile, and very likely a whole bunch of other errors just went away. Okay, so that's an example of a syntax error. The compiler is expecting a string, and it knows it's got a rule that says all strings have to have a quote character, a bunch of characters, and then a quote character at the end to terminate it. It didn't see that, it didn't like that, and there's the syntax error. Really easy to fix. Other times, you may have things that are misspelled. So for example, let's say I spelled end L here wrong. I put an extra L in there. Now when I compile, it's saying error, end LL is not a member of the standard namespace. So it knows that cout is and end L is, but end LL is not. So in this case, this error message kind of leads you to the place where the problem is, and you say, oh, of course, I have a typo. So you can fix that as well. Okay. Another example of a compiler error that's a syntax error is forgetting the semicolon here, let's say at the return 0. All statements have to end with a semicolon, so we just forgot it. That violates one of the rules that the compiler knows about, and it doesn't like it. So what we'll do here, again, we'll compile. And you can see it says error expecting a semicolon before that curly. So there's the curly, and it's expecting a semicolon. Sure is because of that. Okay. Now suppose we just say return semicolon. Now this is problematic because we've told the compiler in our code that main returns an integer. But here we're just returning, we're not returning an integer. So let's see what it says. Let's compile. And it says error return statement with no value in function returning integer. Pretty good statement, right? It's telling you I've got a function. You told me it's returning an integer, but you're not returning any value now. So I can return 0. Okay, so let me show you an example of a semantic error. Something like this. This is perfectly valid. I can return an integer, I can return a string, I can return a lot of things. The problem is that it doesn't make sense to the compiler because you've told it here that you're returning an integer, but now you're returning a string. So let's run that and see what you get. Here you go. Error, invalid conversion from a character star, which is a string, to an integer. So the compiler is trying to figure out, how do I convert that Joe to an integer? I don't know. I have no idea. I'll just throw the error. Okay, and that's up to you now to fix it. So in this case, again, I'll fix it to return 0. Now let's do another one. Let's get rid of that first curly. This is a real interesting compiler error, and I'll compile it and then we'll talk about it. Let's compile, and you can see that I've got 3 errors from that. What's happening is the compiler is totally lost here. The compiler is seeing int main, and then it's expecting a curly, and it's processing more and more stuff, kind of hoping to see that left curly eventually, and it's not seeing it, so it's seeing other things, and it's throwing errors. It's saying, I don't know what's going on before the STD. I've got an unexpected, unqualified something before return. I'm lost. Okay, so when you see these kinds of errors, I mean, this is a tiny little program, and I've got 3 compiler errors. Sometimes you'll compile something, you'll get 20, 40 errors, and many times when you fix that first one, most of them will go away. So in this case, all that's missing is that curly. So I'll compile, and we should have a clean compile now. No, we do. Okay. Sometimes you'll add extra curlies at the end, which again is illegal. So I'll compile. And there it is. Right? Error. I'm expecting something before that token. It doesn't know what you're doing. So we'll get rid of that. Okay, so let's do one more semantic error. Let's say that we've got hello world in here. And I'm going to put parentheses around it, and I'm going to divide it by 125. And I'll put a parenthesis around that. Just simple math. Okay, that's pretty weird. I've got something here divided by something here. That's valid. I can divide 2 things. The division operator, which is that slash, is a binary operator. It works on 2 things, right? So 4 divided by 2 is 2, 8 divided by 2 is 4, and so forth. But in this case, the syntax is correct, but the compiler is going to say, I have no idea what you want me to do here. You're telling me to divide hello world by 125? I don't even know what that means. So let's compile that. And the error is something like error invalid operands. So the division operator, the slash operator, has got invalid operands. There's 2 operands, right? One is a string, the other one is an integer, and it's saying, I don't know what to do here. So these are some simple examples of compiler errors. Don't be afraid of the compiler errors. You're going to get them. Don't let them frustrate you. If you have any that you can't figure out, please post to the forums and I'll be glad to help you out. It's just something that we have to learn to work with because we're going to get compiler errors. We all make mistakes. Sometimes we're prototyping, we're trying new things, and we're getting errors. Sometimes they're just silly mistakes, and they're hard to find sometimes. Sometimes you'll be looking at your own code. I can tell you, this little error here with the end double L, this is a good error message that you got. But if you're looking at this code, and you've been coding for a few hours, I don't think you'll see those two L's. Most likely, they look like one L. So this is the kind of thing that programming is about. One of the important things is getting rid of all these compiler errors. Once we get rid of the compiler errors, then we can test our code and we can look for logic errors and so forth. Okay, so that wraps up this video. In the next video, we'll talk a little bit about compiler warnings. They're a little bit different from errors because they're not true errors, but they're telling you something that you should look out for. In this video, we'll talk about compiler warnings and why they happen. Big tip. Don't ignore compiler warnings. We'll talk more about that in a minute. The compiler has noticed a potential problem in your code and it's warning you about it. That's what compiler warnings are all about. It's only a warning because the compiler is still able to understand your code and produce object code from it. However, it's letting you know to be aware that something could be problematic. In this example, we've declared a variable called miles driven, and it's an integer. It can hold any kind of whole number. Then on the next line, we display the value of miles driven to the console. The compiler produces a warning here. It's warning us that you've used the variable miles driven, but you never initialized it. So in other words, the value that it contains could be anything. Once again, don't ignore compiler warnings. Many programmers treat them as errors and fix the potential issues up front. Let's head over to CodeLight and we'll see some of these warnings. So now I'm back in CodeLight and I've created a project called Compiler Warnings. And again, it's a default project, just simple hello world. Now what I'd like to do is, let's use that favorite number variable again. So let's create that here. I'm going to say int space and the name of my variable. Let's call it favorite number. Perfect. Now, suppose I want to print out that favorite number. So I'm going to remove this hello world right here, and I'm just going to replace it with favorite number. So that's all I want to do. I've got a favorite number. I'm going to print it out. Now, if I try to compile this, syntactically, there's nothing wrong with this program, but there is a problem, and the compiler's warning you right here. It's saying favorite number is used uninitialized in this function. So in other words, you haven't told the compiler what the value of favorite number is. You haven't asked the user to input anything into favorite number, and you're going to print it. The compiler's telling you be careful because anything could print here. And in this case, anything will print here. So let's run this so you can see what it looks like. I'm going to run, I'll build and execute. And look at what favorite number is, 4200971. Probably not what you expected. That's the reason for the warning. The compiler is telling you, you never set that variable to any specific value. So when I print it, who knows what's going to be in there. Okay, we'll talk more about that when we talk about variables. So that's one of the issues that you could have. Another issue you could have is, let me go back to Hello World here. Another issue you could have is, suppose that in this case now, we do assign something to that favorite number. Let's just say favorite number is, I don't know, 100. So look what we've done now. We've created a variable, we've assigned a value to the variable, but we haven't used it. So the compiler's thinking, wait a minute, did you plan to use that variable? Why did you create a variable and not use it at all? So we'll compile, and the warning is variable favorite number set but not used. Okay, so it's telling you, are you sure you want this? There's no reason for you to create a value and then not use it. And similarly, if I get rid of favorite number here and I just do something like that and compile, there's the warning again, unused variable. You've created a variable, but you haven't even used it. So what do you want? The idea is you should have a no warnings policy in your code. You should have clean compiles with no warnings. Now there's many, many more warnings, and we'll run into them when we talk about if statements and looping and assigning and doing math. And we'll talk more about those warnings when we get there. In this video, we'll talk about linker errors and why they can happen. Linker errors occur when the linker is trying to put all the pieces of a program together to create an executable, and one or more pieces are missing. Typically, this can happen when an object file or libraries can't be found by the linker. Fixing linker errors can be tricky. Sometimes it's just a matter of getting the paths correct so that the linker knows where the missing pieces are. Let's head over to CodeLight, and we'll force a program to have a linker error so you can see what the error message looks like. So I'm in CodeLight, and I've created a project called linker error based on the template that we use. So all I've got is a main CPP file that says hello world. Now we're going to force a linker error here. This is not something you want to do normally, but I want to do it to show you what the error looks like. So what I'm going to say is I'm going to say extern int c, or let's just say x. And I'll explain all this to you in just a second. And then in the body of the main, I want to try to use that x right there. It's just an integer, and let's say I want to print it out. I just want to print out x. Simple as that. I'm going to save this. Now you'll see if I compile this program, you'll see what happens. I'm going to right-click, compile. I get a clean compile. There's nothing wrong with the program. Okay. But when I try to build and run it, you can see the linker error. This is classic linker error, undefined reference to something. In this case, it just happens to be x. Also, you'll notice that the linker returned 1 here. LD returns 1, which is the exit status. So something was wrong with the link. Obviously, the compile was fine because we got no compiler errors. We do that again. There's the compile, no errors, no warnings. So let me explain to you what's going on here. Let me grab my stylus here real quick. And what's going on here is I've got my main CPP file here, and it's going to be compiled to main.o, let's say, or main.object. In here, we have a reference to an x. You can see it right there. You can see it right there. So in here, I've got a reference to an x, which I'm going to use. Now, we also have our IOStream libraries. So the linker needs to grab those libraries, and I'll just type IOStream here so you'll know what I'm talking about. The linker needs to put these two together to create my main.exe. Or in this case, I believe it would be linkererror.exe, but you know what I mean. So the compile is fine. We've created our object file. This library exists. The problem is that I've told the compiler here that this x is not in me. It's somewhere else. It's defined by somebody else. Well, obviously it isn't defined by someone else because that kind of forced the issue here. So now the linker needs to resolve that x. It's saying, okay, where do I get that value to print? Because that's what you asked me to do right here, right? I wanted to print the value of x. Where is x? It can't find it. That's the linker error. That's exactly what's going on. And let me build this again so you can see the error message one more time. Let's build it and run it. And there's the error message. It's saying undefined reference to x. You can see exactly what's going on. It can't find x. Now, this is not a compiler error. This is a linker error. That's really important to understand. Linker errors are tricky to fix. A lot of times, the files that you need to link are missing. They're in the wrong places. You don't have to worry about that using CodeLight. In this course, we're going to basically do everything ourselves. But if you're using libraries from third parties, this is the kind of thing we'll talk about in a more intermediate or advanced course. But I just wanted to show you linker errors in case you do come up with one. Post it in the forum and we'll work through it together. In this video, we'll talk about runtime errors and why they can happen. As the name suggests, runtime errors are errors that happen when the program is executing. These types of errors can be difficult to predict when we're writing our program. These errors include divide by zero errors, file not found errors, out of memory errors, and many, many more. Some runtime errors can cause your program to crash. We use exception handling to help us know when runtime errors happen so we can try to recover from them. We'll see examples of runtime errors later in this course when we work with files. We'll also work with exception handling toward the end of the course. In this video, we'll talk about logic errors and why they can happen. Logic errors are errors or bugs in your code that cause your program to run incorrectly. Logic errors are mistakes made by a programmer. Sometimes the mistakes are careless, other times the mistakes are because the programmers have incomplete or incorrect information. Other times mistakes occur when one programmer modifies another programmer's code to fix or add something, and they introduce an error as they do this. There are many, many causes for logic errors. It doesn't matter what the cause is, though. They need to be corrected. We need to test our code and debug it to find and correct errors. Suppose we have a program that determines if a person can vote in an election, and you must be 18 years old or older to vote. We haven't talked about if statements yet in this class, but they're very intuitive, and I'm sure you'll follow this little piece of code. First, we test to see if the age is greater than 18. If it is, then we execute the code that's inside those curly braces. Do you see the error? It's pretty easy to see it here because the code is isolated, and I told you there was an error. However, in reality, there's much more code typically involved, and this may just be a small part of a much larger program. The problem in this code is that the test condition should be greater than or equal to 18, or greater than 17. Either one will work. As it's written now, 18-year-olds would not be able to vote. We'll talk about testing throughout the course in the context of learning C++ and best practices. Well, that wraps up this section. Next, you can take the section quiz and attempt the challenge exercise and see how you do. I'm sure you'll do great. If you have any questions, please post them to the course forum. Welcome back. So you're ready for the section challenge. Let's go over the challenge. Create a C++ program that asks the user for their favorite number between 1 and 100. Then read this number from the console. Suppose the user enters number 24. You want to display the following to the console. Amazing. That's my favorite number too. That's exactly what we did in our first program. Now here's the little bit of a twist. You also want to display, no really, 24 is my favorite number. Below are 2 sample runs of the program. So in this case, we're prompting the user. There's our prompt. The user enters 24. And we print out amazing. That's my favorite number too. No, really, 24 is my favorite number. And if I run this program again and I type in 75, I'll get 75. So let me run the program for you so you can see what it looks like. Here we go. This is the prompt to the user. Enter your favorite number between 1 and 100. So let's say I typed in a 50 and press enter. Then you're going to display to the user, amazing, that's my favorite number too. No, really, 50 is my favorite number. That's it. That's the challenge. That's it. That's the challenge. Give it a shot and then come back to the next video and we'll work through the solution together. Welcome back. I hope you were able to solve the challenge. Let's go over it together and I'll give you my solution to it. This is a pretty simple challenge, but it's important that you get it because we have to be able to compile, build, link, and run. Obviously, we don't want any compiler errors. We don't want any compiler warnings. So let's start here. What I've done is I've created a challenge solution project based on the template. And here's my main CPP. It's just a simple hello world. So this is the one I'm going to modify. All right, so let me change a little bit of this. I'm going to get rid of that statement right here. And we'll totally start from scratch. Now remember, we need to include the IOStream library. This is how we do input and output. This is how we do our cins and our couts. So first thing I want to do is I want to prompt the user. I want to say std, 2 colons, and cout. And there's my insertion operator. I'm just going to simply say enter your favorite number between, let's say, 1 and 100. And we'll put a colon there and a semicolon on the end. That will prompt the user. Okay. Now we want to be able to read that number from the user. Remember, when we read something, we need to store it somewhere. So we need to store that in a variable. In this case, it's going to be a whole number, so we're going to use an integer. So I'm just going to say int favorite number, just like we did with that first program we wrote. So that's my favorite number. Perfect. Now I can read into that variable. So I can say std from cin. I want to extract, so I'm using the operator going the other way, into favorite number. Okay, so at this point, I've prompted the user. They've typed in a number. I've read that number, and I've stored that number in this favorite number variable right here. The last thing to do is to print out those 2 statements. So first I'm going to say Cout, and I'll say amazing. That's my favorite number 2. And we'll print a new line here so we can go to the next line. We'll say Andel, followed by a semicolon. And this is the only difference now between this program and the one that we wrote previously. We want to be able to display the number. Say, no, really, whatever you entered was or is my favorite number. So in this case, let's do that again. We'll do std, and we'll do again cout, and we're going to write to that stream. And I'll say, no, really. And I'll put a comma here followed by a space because we want this to be spaced out nicely. And I'll show you what the problems may be if you don't do that in a second. And at this point, we're going to insert our favorite number right in here. And we'll do another insertion operator. Remember, we can stream all these things together. We can do as many as we want. And we'll say space is my favorite number. And we'll finish it off with a new line. Let's try that. We'll go up to Build, Run, and Build and Execute. We got a clean compile and it's running. Enter your favorite number between 1 and 100. Let's say it's 10. Amazing, that's my favorite number 2. No, really, 10 is my favorite number. Perfect, that's exactly what we wanted to solve. Now, the reason that I put in these little spaces here is because let's say I don't put that space in there, and I don't put the space in here. Just like that. And let's run this again now. You can see that the output's not going to look right. So in this case, let's say I typed in 25. And you can see, amazing, that's my favorite number 2. That's fine. But now look, no really, comma 25, no space between 25 and the little I for, and the lowercase I for is my favorite number. So you can see that the output doesn't really look very nice. So all we're doing is just formatting it. We'll talk more about writing to streams and using manipulators so that we can really get more fine-grained control of what we want this to look like. But for now, we could just put spaces right in here. And we'll try that again. Build and run. My favorite number is 10. No, really, 10 is my favorite number. Perfect. So that's it. And that's the solution to this challenge. As I said, it's a pretty simple challenge, but there's a lot of pieces here that come together. In the next few sections, we'll talk about the structure of the C++ program, as well as variables. We'll talk a lot about variables, how we declare them, how we define them, how we initialize them, and how we use them. But you got a taste of it here.